right, so today in this session, we're going to talk about, generally speaking, what are the major types of AI workloads and what are the storage requirements. And this is something that most people tend to sort of, overlook because there is a lot of focus on compute, but there's a big aspect around storage in terms of data access, freshness, security, and all of those things. So we talk about that. We'll go into a bit of demos on training and fine tuning. So it's a very, very demo heavy session. And I will apologize for the fact that we won't be able to take questions in the middle of the session, but we will try to devote some time at the end. And of course, you can see us at the Microsoft booth at the Expo Hall as well. And finally, we'll talk about one of the most talked about topics in enterprise AI, which is RAG, and how do you perform RAG effectively at scale with ADLS and Databricks. Jeff?
Yeah, so assuming that you guys know what an LLM is, what a large language model is, and when you want to bring a large language model into the enterprise, you obviously want to add your enterprise context, right? Your domain knowledge to that, right? So you have three ways of doing that. The way that most people start off is by doing some type of prompt engineering, where you might start off with a basic prompt, you then customize that over time, like say, hey, I'm a program manager at Microsoft and I work on Azure Storage and la 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 la, and then I'll add in maybe attach some files and things like that to provide it more context. That's usually the way you start. But then when you want to sort of expand on that, you might do something called fine tuning. Fine tuning it's like you take a trained model and you apply a set of parameters and weights to those parameters and get a further refined model. A good analogy of that would be like, say, hey, I'm a chef and I have a basic recipe, but now I want to make that recipe mine, and maybe I have like a food blog or something, and so now I want to like tweak that recipe a little bit. I'm going to fine tune that recipe.
If I was to talk like Jeff,
please don't.
Jeff style, it's very hard, by the way. Then I need to fine tune myself and essentially change the way I talk, the way I stylize all my statements and so on. So that's fine tuning, which is essentially learning new skills as far as domain knowledge goes.
Yeah, like when I met my wife, right? She applied a lot of fine tuning on me.
Oh, you needed it.
Yeah, for sure. I'm still being fine tuned. Okay, it's a work in progress. Okay, so here we go. And last is RAG. So retrieval augmentation generation is essentially taking those facts, and we'll get into this. Like Saurabh's got some awesome demos about on RAG, so I'm not going to spend a lot of time on it right now. But essentially, it's taking a database of knowledge, and you're applying that knowledge to a context or prompt to then fine tune the output. Okay. Since we're at the Databricks Data and AI Summit, I'm going to assume that most of you, if not all of you, know what what an analytics pipeline looks like, right? You probably have built many of them yourself. So, you start off with some knowledge or you're collecting the data somewhere, you're sticking it in a data lake, hopefully ADLS. You're then doing some munging, some cleaning over it and whatnot. Then you stick that in storage again. Then where the AI training part comes in, like you'll take that clean data and now you say, all right, well, maybe I don't want to look at all of the data, or maybe I don't want to look at all the clean data and use that as training. Maybe I want to use a subset of that or something, right? So then you figure out what data that is, and you then use that to train your model. And then during your training, you are checkpointing. Checkpointing is effectively like saving your work, so that if a GPU or a VM fails or what have you, you don't have to start from zero. Yeah, right? Because that's a lot of money. And so then you take at some point you'll probably use some of that checkpoint data to then influence your base model weights that you put, the weights that are assigned to the parameters. And then ultimately, what we're trying to get to here is the inferencing, where you deploy the model and you do the things.
Yeah, one observation here which is to note is the lower part of this diagram essentially shows what happens at storage. And if you observe, there is a lot of input and output going into storage, out of storage. And so there is a lot of requirement in terms of serving the training framework, ensuring the checkpoints are fast, because these are huge models. They are billion parameter models, and their checkpoints go into hundreds of gigabytes, sometimes even terabytes for the final model weights. You need that kind of throughput, that performance to be delivered by your storage system.
Absolutely, absolutely. So let's talk a little bit about storage, or specifically Azure Storage. So we have many protocols that we support. You have blob storage kind of serves as the foundation, right? Then, on the left-hand side, you got the blob API. That's been around since the beginning. And about 6 or 7 years ago, we GA'd ADLS Gen 2, but now we just call it ADLS period because we deprecated Gen 1. So we're now saying, hey, there's no more Gen 2, it's just ADLS. And this is essentially your file system. It fully supports Hadoop semantics. It's a truly native file system that's in cloud storage. It's pretty cool. And then NFS for your file serving, and then SFTP for like really old legacy systems. Yeah. Real quick, we have various offerings. We have the standard storage, the premium files, NetApp files, so on and so on. Some of the interesting parts here is like the storage accounts can scale up to hundreds of petabytes. They can do well over a terabit, and you'll see in one of the demos multiple terabits per second. There's all sorts of good, and we're always increasing these limits all the time. For today's session, we're going to focus on standard and premium blob or ADLS.
Yeah, and the other takeaway from this slide is that we just blocked over here with the captioning.
Oh yeah.
But premium blob essentially is the ideal platform for low latency, and consistent low latency is sometimes what you need when you're working with extremely large corpus of documents, whether it's structured data, unstructured data. You really need that kind of low latency to be able to extract information, prepare that information inline as your query is essentially coming in. Very, very relevant for RAG. And so what we've seen is premium delivers 3x faster performance than standard blob for RAG applications, and also saves 65% on transaction costs. So we'll see some of that as well in today's demos.
All right. Oh, no demo yet. Hang on. So let's get a few more slides, and then we'll get straight into the demo. So we're going to talk about fine-tuning pipeline. So we have the things on the left that we've already kind of talked about. You're ingesting the data, you're cleaning it, you're preparing it. Now, within the fine-tuning world, you take that training data, you have your base model weights, then you are applying, you pick a model, right? There's many models out there. You can check them out, Hugging Face, Databricks has some, we have some, OpenAI, like there's a lot of models, right? And so you pick a model that ultimately does what you want it to do, like or is close to what it is that you're trying to achieve. And then you use your data to then train or further refine that model. And then you're doing this over multiple iterations, right? You're doing this, there's multiple layers of neural networks in these models, and at each iteration, you might want to save it, you might want to checkpoint it. Usually you don't do it at every iteration, you might do it at every 15 or 20 iterations or something. It really just kind of depends on the model and what you're trying to do. Yes, so as far as the storage is concerned, right, like what do you, kind of like Saurabh was talking about earlier, right? You want a storage system that scales, you want it to be, obviously cost effective, you want it to support multiple protocols to handle ingestion from all types of data sources, and you also want it to manage, you want to have some type of governance and access control over this data, right? I mean, especially when we're talking about domain data, like this is your company's IP, right? Like this is super, super important stuff. And what is it? It's like every week we see yet another headline of some other data leak and some other, right? Like it's just becoming, it's crazy town. Okay, all right, so let's go into pray for me. Let's go into a demo here. So you want to set the context for the demo while I get this?
Sure, let's do this.
Go ahead.
So one of the things that's very important, and as you saw from the previous slide as well, during fine-tuning, you need optimized node local access to data. What does that mean? Your GPUs are costly. You don't want to have them sit idle. At every single time when you are essentially training your pipeline, your GPUs should never, ever be starving of data. How do you do that is you essentially have some sort of a way of having storage serve the GPU nodes without any interruption, with extremely low latency and high throughput. And that's exactly what BlobFuse 2 does. BlobFuse 2 is essentially an open source mounting platform for Blob that allows Blob storage to be connected, or ADLS storage to be connected, to any AKS cluster via the Blob CSI driver, or to even any VM, as if it were basically just locally mounted storage. And the semantics on this are pretty powerful, because you can treat ADLS as your local file system. So essentially, whatever data you have, it is served up to the VMs or the AKS cluster via the Blob CSI driver, and that way your GPU nodes are never sitting idle. So what we're going to show in this demo is two sets of things. When you're fine-tuning, you want your checkpointing process to be super, super fast. Why? Because if you're writing the checkpoint, and these are very, very large files, if these are taking time to be written to, your GPU nodes are sitting idle, right? Similarly, when you're loading the checkpoint, you want extremely write egress or high read throughput, again, because your GPU nodes should not be sitting idle. And so with this demo, what we're going to show is two things: writing checkpoints, reading checkpoints, and I think Jeff has got a surprise for us as well with regards to some parameter-efficient fine-tuning as well.
Okay.
All right, we are not able to replicate the screen, so we're going to just dock them in here.
You need to tell me where the mouse is?
It's right there on the upper right quadrant.
Hang on. This is nutty.
Live demos.
Oh my gosh. Hang on.
There we go.
Uh-huh.
It reminds me of
Where'd my mouse go?
Interstellar. We're trying to dock here. All right. I think I can see
I'm just, where do you see it? You see it?
I see the
I
other
see it,
screen.
I see it.
Screen there.
All right. Oh my God.
Might have to go up.
There we go. All right.
Yeah, there we go.
Okay, so on the left is, so this is, I'm in the same VM. I just have two tabs, right? On the right-hand side will be, or should be, the...
That's the end load. That looks like the end load.
It should be. Oh my gosh. I can't see.
You want to take your laptop here and move across, maybe?
I can. It's all tied into everything.
Yeah. I can tell you what you're typing.
Okay. So and I can't see what I'm typing because of the captions. Inload 35, 3, 4, 5, 6, dash 35.
There we go. All right, we're in.
All right, so on the right-hand side is essentially, it'll show local network saturation, right? So I just wanted to have that up so when...
And just so I can sort of explain, on the right, what you see is nload, which is a network monitoring tool, as Jeff said.
All right.
On the top is the incoming characteristics, which is what is coming into the storage system. And on the bottom is the outgoing characteristics. And now we're going to run some commands, which are going to show.
We're going to try. We're going to really try. I'm going to give...
Let's try this out.
So first thing is Python. Nope.
We just copy paste and that's...
Dude, copy paste isn't.
All right.
Is that? Dude, I can't see. All right. You see my mouse over there?
No, not yet.
This is supposed to be the easiest demo, and yet I can't see anything.
So just to tell you what's happening, this screen is not something that Jeff can see on his screen right there on the laptop.
Yeah. I'm just going to type it out.
Yeah.
UI
Now we can see it.
50.
There's a spelling mistake. I love the folks. Yeah, you got Python's 3. Right there.
Yeah?
Yep.
Send it.
Looks good. Oh, you have to just change the folder on it.
Oh, dude. I forgot to.
Yeah.
All right. I got to mount.
So this is a simulation where we're going to read some files, 50 gig files.
Fuse,
And imagine these are
mount.
checkpoints. We're also going to show a write file where we are going to see the network characteristics on how the read-write works as and when the command comes up.
Oh, no, it's the wrong window.
Yeah, it's typing in there.
All right. Blob, fuse, to mount, HNS, blob, fuse, mount. Am I typing it right? Did that complete to the YAML file?
Looks like it.
Yeah?
Blob fuse,
What does that say?
unsupported config type. Just copy paste the thing.
I can't see because the.
Yeah, the YAML didn't come in. This one. This YAML file.
Yeah, that's what I was typing.
So this is beyond this.
Yeah, I'm already in there. They just need to run that. Yeah, you're there. Go ahead and click and right click. All right.
No, it's hard to read.
I can't see with the captions. Do those captions really have to be there?
And loaders.
Oh my God.
It's hard to see from here. How about you bring it up and then dock it back in?
What does it say?
It's very hard to read this. Invalid config file is what it says. Maybe we should go to the other one.
What's that? Okay, so let's just go. We can just skip to the fine tuning one. Yeah,
Let's do
okay.
it.
So here's a cooler video. We're just going to skip over this, all right? Because in reality, we actually have a guy who he ran an actual fine tuning on.
Let's maximize it.
Yeah, I'm trying. I'm just trying to get to the window, dude.
Yep.
Okay, awesome. So what we were trying to just do was simulate what this is actually doing, right? And the reason we were trying to show the other thing that we can't really see what we're typing here is because it was showing that we could saturate the NIC before you even run into any storage throttling or anything like that, right? But here, and it's essentially meant to like, hey, you do that fine tuning like we talked about. You're reading a very large model file into one VM or multiple VMs, and so that's going to be egress from the storage account and reading in, and then you are writing checkpoints to the storage account, which is obviously ingress. Okay, so this is a video because what Wolfgang, our partner in crime in Italy, he is using spot VMs, right? And if spot VMs are, like the great thing about spot VMs is that you can get it about 10% of the cost of like a dedicated VM, which is nice. The downside is you can get booted off at any point, right? So that's where checkpoints really become valuable, right? Because you want to be able to, when you get another VM allocated again, right, when a spot VM becomes available, you want to be able to resume from your last work, right?
And I think just to add to that, why does it matter is a lot of enterprises, and we hear this a lot from enterprises, where they say, hey, fine-tuning is hard because first, it's so costly. So this is a very cheap way of doing fine-tuning. And the reason we are able to do that is because these spot VMs, as Jeff mentioned, are writing checkpoints super fast, but also reading checkpoints super fast when they come back in.
Right.
Let's see that in action.
Right. So here so what we have here is just the storage account called build 24 blob fuse. Hierarchical namespace is enabled, which is essentially saying, hey, this is an ADLS account. Let me hit the play button. Right. And I kind of need to hang on so I'll make sure. Right, so what he's walking us through here is he's showing us the structure. So he's walking us into the input container. So the input's going to contain the model, other files and things that you want as part of the fine-tuning, right? So he's showing all of this, Python files, other files. This is the Mistral 7B model. Which 7B stands for 7 billion parameters, and the only reason we picked Mistral 7B is because we could actually load the entire model onto a single VM, right? So no other reason, just to keep costs down, because we're running, these are very large, these are VMs.
Multiple number of, I think 17,000 or something cores that we are using, and there are several.
No, that's for the other thing, right? But yeah, but this one has two AC100s, is it?
Right.
The NVIDIA AC100 GPUs, which are nice. Okay, so here's the checkpoint folder where he's saying the checkpoints will be saved. He's just showing here that he uploaded the Nemo image. That's the that's the model into the container registry just to speed things up a little bit. And as he's showing here in this top caption, so hey, we're using a single NC48 ADS powered by two A100 NVIDIA GPUs. Okay, so now he's just showing, hey, that bottom thing that he just highlighted is the actual running node. He's just getting into K9S, which is a open source Kubernetes utility to it's really nice interface in terms of managing. So he's just showing that, he's just kind of walking through the configuration here, and I'll pause it for a second. But so Azure Blob CSI driver is used to define PVCs with Blob Fuse. So Blob Fuse 2 is the client driver that allows a storage account, whether it could be a Blob account or an ADLS account, to appear as local to the VM, to the container. Right, so let's go look at the job definition. I'm just going to kind of speed things along here a little bit. I can really hardly see. So the main thing we want to look, so this right here, steps equal 30. Get out of the way. That is saying, okay, at 30 steps or 30 iterations, I want to write a checkpoint file to storage, right? This is obviously configurable. He could have done every one step or 200 steps or what have you. Maybe not 200, because I think the max number of steps is 180. And yeah, so these are two mount paths, input and output. Can you hit the space bar again? I do it. I'm just going to hang out here for a minute, because he scrolls down for a second. Yeah, it's showing output / all right, hit pause it. So yep, GPU 2, so 2 GPUs on this VM. I want you to use both. He's doing stuff on the bottom. You can't hardly see it. Okay, so he's just showing, this is Can you hit pause again? Because I just remember. So what we're going to do is he's going to bring this thing up. He's going to bring up the VM, and then after it's brought up, he's going to kick off the job to start the fine tuning, and we're going to let that run for a little bit. I think he allows it to run to get that first checkpoint file written to storage, and then what we're going to do is we're going to evict the VM. We're going to kill it, right? So then to simulate as if someone took that spot instance. All right, hit the spacebar. Thank you. So he's just showing pod initializing. It's just waiting to come up. It's running. Great. It's ready to go. Now, unfortunately, it's down here. It's really sorry about this, guys. But he's started the job, right? So it's doing things. Yep. It's blah, 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 it's doing the thing, and I think he'll show, yeah, so right here he's just gonna show, all right, hit pause it. So, wish I had the
Clicker?
Yeah, give me the clicker.
Good catch.
So right here, and so remember it's 2 GPUs on the VM, right? So right at this moment when we paused, we've got 100% on one and 55% on another, 100 on one and 57% allocation on the other. Like these are the GPUs. Okay. I think you can. Right. All right. So he's showing the checkpoints. There it is, right? There's that first checkpoint. You see step 30? Because that was in the configuration to write a checkpoint every 30 steps. So that's what he's showing there. I'm so glad that we had him do a video now that, oh my gosh. All right, so now, hit the left arrow real quick. Let me go back.
Go back a bit?
Yeah, just a few seconds. All right, pause it. Go back. And pause. All right, so here, simulate eviction. So now he's gonna kill it. Here's the name of it, here's the instance. All right. So he's just gonna go and, okay, here we are. So the way AKS works is that as soon as it detects that one has died, it's going, if a spot VM is available, it will try to spin up another, and that's what is happening here. Right. Ignore the succeeded thing. Like the succeeded is like, hey, I successfully died. It's kind of weird Portal language. That bottom one is the one that is being spun up, and it is now ready. So it's just showing things are getting initialized on the VM and so on. You hit that right arrow, we can kind of fast forward.
Yeah.
Just kind of, yep. It's becoming.
Yeah, this is the restart where it'll pull the container image and.
Mm-hmm. So it's pulling the container image. Fast forward. Yeah. Okay. Pause. So. Actually, play it again. Yeah. Not yet. Okay. Well, I guess I can't really. Yeah, I think it's down here. It's saying, hey, I'm resuming. I'm resuming from the checkpoint. By the way, we'll be in the booth, so for any of you skeptics or whatever, you're like, you're suspect. You're already showing us a video. We don't believe you. Whatever, we can show you. Huh? It's not, but that's a good idea. We just come out of the booth and we'll get your contact information. Make sure that. Sneaking a question in. Good for you. Yeah. Okay. So we're already at the end. Can you rewind when I want to show it, and then we can at the portal view. Uh-oh.
Uh-oh.
No. Okay. Well, anyway, what I was just trying to show is that it wrote the last checkpoint, which is at step 180, and that's where like that was 180 steps, and it's basically done. So anyway, that's I think that's pretty cool, actually, right? Just to show that you can resume a VM, like storage cost is gonna be nothing compared to running a VM of this magnitude, right? So you really want to maximize your compute, right? You don't want it to start from zero. That's the whole point. But the other big point, since we're from storage, is to highlight the performance of storage, right? Like, yes, I want to write checkpoints, but I also don't want my compute sitting around twiddling its proverbial thumbs, waiting for the checkpoint file or the model to, to load or to write to storage. That's kind of the point. How are we on time? We are not good on time, so let's
speed through, and I think let's show the results which we got on the IOR benchmark. So just to give you some context, this is actually a usual benchmark for HPC systems. This should not be a surprise. The IOR benchmark is pretty well known. But what is interesting is on the right, we use 17,000 cores. Broca Leadership's Bank, by the way, Jeff's manager is also here. We might not have a job after this. But at the end of the day, what is important is we had 17,000 cores, and we essentially wanted to push the limits of our storage account. It was a single storage account that we essentially connected via Blobfuse 2, and these were the results. It's not visible here, but we were able to achieve a peak ingress of 8.1 terabits per second and peak egress of 13.5 terabits per second. And you need these kind of speeds because if you're looking at a terabyte scale model, which has that many model weights, it should just be a matter of 8 seconds to be able to write that 1 terabyte back as a checkpoint and read that 1 terabyte back again from the storage account very, very quickly. So your GPUs are never starving.
Okay, so let me thank you, Saurabh. So RAG.
Yeah, we've got very little time left, but what we're going to do is we're going to focus on some of the key aspects of how does this thing work? Okay, key aspects of RAG. I mean, this should not be new to any of you. But what is important is we want to talk about the pipeline a bit because the pipeline becomes quite important. In the pipeline, again, it's similar to training and fine-tuning, except now you have domain-specific data, which you then want to load up and clean up. There is a lot of PII in it, perhaps, that you want to remove. You do all of that using ADLS and some Spark jobs with Databricks. But on the other side, what you have on the inference side, you have the model weights, as you would normally have with a fine-tuned model or a base model. And now you want to generate a response which is retrieved based on the user query that comes in. And that's what happens in the middle. There is a very important piece, which is the vector DB, which is what stores the embeddings. And models don't speak English. They speak vectors. And so whatever English you have or whatever other language documents you have, you need to convert them into embeddings and then store those embeddings. And then RAG essentially becomes a retrieval job. A query comes in. You essentially figure out what is the similarity of the query to all the embeddings that I have in the vector DB. And then once you retrieve those embeddings, you are then passing that same context into the model as prompt augmentation. But what you want to do here is you want to make sure that access is secure, right? Because you don't want, I wouldn't like to sort of look into Jeff's documents. Even if I would, I should not be able to.
Yeah.
Santosh is smiling here because, who knows? I mean, we know what, how much he's making and stuff at Microsoft.
I can look at your stuff, man.
Yeah, exactly. So you don't want that. And so that's why it's very important to have that secure access, built into your RAG pipeline. The important things to call out, storage is the one that contains the cleansed data chunks. Why do you need to chunk? Because these models have finite token lengths, finite context lengths. If you pass your entire corpus, which is possible, you are, of course, going to consume a lot of tokens and therefore pay a lot of money. And so it's not the most efficient to be able to do that. And therefore, chunking allows you to break down your corpus and then essentially have the model being served with those chunks.
Let's do the demo.
Let's do the demo quickly. We have 5 minutes, I guess.
Yeah. Did you switch over?
Let me see.
So what Saurabh's going to get set up is, so what we're doing is we're going to show RAG in Databricks.
Yep.
So you guys know about vector search, right? That's the Databricks vector database.
How many of you know about vector search?
Show of hands.
hands.
People know about vector search?
Then we can skip. OK.
That's
all right.
Good. Yeah. And so we set up Unity catalog. We set up Delta table. We chunked. Well, I'm not going to spill the beans and everything, but you know.
All good. So this
cool.
is where this is the ADLS premium account where the knowledge base is kept. It's actually kept in these containers here. There is a bunch of PDFs here. And the reason we chose PDFs is because while they are unstructured, you still actually convert them into structured information so that it's easier to retrieve exactly the amount of chunk or amount of data that you need for that RAG application, right? So this is our corpus. This I have a Databricks workspace where, as Jeff was mentioning, we've set up, vector search. So Databricks vector search is the vector DB in this case. And if I go in, I can actually see this vector search is already populated. There is a bunch of data in here already. And now what we're going to do, so you can see here, there are 1,320 indexed rows. We're going to go to, a notebook, and let's look at a RAG application. So this is my notebook, and I'll just walk you through what I did here. Essentially, first thing is data preparation and chunking. I'm not sure if people at the back can see, but I'll probably, is it visible?
Can you guys see in the back?
At the back?
Awesome.
OK. So data preparation, chunking, and ingestion is the first step. And here we are using the LangChain community libraries to be able to split text. And then what we're doing is we're essentially loading those chunks into a Delta table, right? And that is what is essentially happening. These chunks are getting saved to a Delta table. Now, the vector search DB is hooked up to this Delta table via a mechanism called Delta Sync. So whenever there is a change in the Delta table, the vector search indexing gets triggered, and essentially that's what updates your embedding. So let's try a query. The query is right here. What is grit in AI? Let's run this and see what we get. There is no grounding, by the way, on this query. And we see, grid is not a standard term used in the field of artificial intelligence. It's possible that it may be referring to a specific concept or application, but it doesn't know what grid is.
Because it says why doesn't it know what grid is?
Well, it probably knows what grid is, but doesn't know what GRIT in caps in AI is. And then what we do is we essentially perform similarity search with vector search. So whatever was our query, we take that query, and as you can see here, we are doing index.similarity search here against my query, the user query, and I'm retrieving the top 5 results. And this is my context. This is my new context that I retrieved from vector search by looking at what are the top 5 vectors which are similar to my query and retrieving the chunks corresponding to those vectors. Now, the last thing that I do is to augment those retrieved chunks. So let's run this as well. And now what I'm going to do is augment the retrieved context to the user query. So that's what is happening here. And this is what is called a meta prompt. So the prompt that comes in from the user is the actual prompt. But once I combine that prompt with the context that I retrieve, I form a meta prompt. And that is essentially a conjunction of the context and the user query. I then send this to DBRX LLM instruct. That's the model that I'm using. And then let's see what answer I get here. OK. GRID actually stands for Generative Representational Instruction Tuning. And it's essentially coming from these PDFs right here. And I think I have this PDF as well. Let me just open.
Do you guys understand what just happened? Right? We augmented the prompt because we pulled out the relevant data from the RAG, from the vector database.
So it's right here. It's in the top. It's in the abstract. It's basically getting it from all over the place in this document. And it actually shows me those nifty references as well.
So we chunked this document and stuck the chunks into individual rows in a Delta table.
Oh, and by the way, the big thing about RAG is dynamic knowledge base. Your knowledge base keeps changing. And so when it changes, how do you track these changes? How do you reindex? There's a pretty nifty feature with ADLS. It's called change notifications. Some of you might already know about it. I can actually set up an event subscription, because what we can do is we essentially post events into event grid. And so I can set up an event subscription and have a function call in that event subscription. So I'm doing that over here. This is my function call, and you can see there were some events that were generated based on some changes that I made. This is my function trigger. Now, this function trigger is essentially able to call a Databricks job to be able to process or reprocess whatever new things I've added or deleted from my knowledge base. And that's pretty exciting because what that allows me to do is to not just essentially invoke this job, but as I invoke this job, I can then process my index, refresh it, and ensure the next time a query comes, that refreshed index is used for generating the embedding similarity and the meta prompt. So let's see this in action as well very quickly. I'm just going to wing this because I've not tested this before, but what I'm going to do is I'm going to go to my containers and I'm going to delete one of the PDF documents.
You're really testing the demo gods, man.
Let's delete this one right here, and this should actually kick off a Databricks job run right here, and I think it did. It's awesome. Right here. So this one just got kicked off right now, and it's essentially updating my delta table and vector search index so that when I come back to my query and run it again, I'm just going to get an updated response. So that was RAG. We'll get back to our deck and close with some closing comments. We are way out of time.
We're way over time. We're essentially, so that was RAG. That was really cool. Thank you, Saurabh. Really just wanted to show here on the bottom, well, you can't see it, but the raw data is an ADLS standard, the cleansed, chunked, and delta tables in ADLS premium for the super low and consistent latency.
Yep.
And all of this is managed through the Unity catalog, which we didn't get a chance to show you, but it's there. If you want to come by the Microsoft booth, we can show you there.
And then I want to talk about very quickly about some of the key things that ADLS offers across multi-protocol. You need multi-protocol because your ingestion might be a different pipeline, your analytics engine might be a different pipeline. You don't want to create silos of data by copying them. So multi-protocol is super useful. You need low latency access, as we talked about, because you're chunking, right? You're chunking, you're writing those chunks into the storage account, and then when the retrieval is happening, you're reading those chunks out. So that's what requires low latency. And then finally, freshness with change feed, change notification. Most importantly, security with Entra ID, ABAC, and RBAC.
Guys, we don't want to hold you hostage anymore. So that, our time is up. We appreciate you guys coming. Thank you so very much. And yeah, thank you.